Hello everyone and welcome to my channel. So in today's question, we have been given few metal ions. Okay, you can see here the question. Identify the metal ions among CO2 plus, Ni2 plus, Fe2 plus, V3 plus and titanium 2 plus having spin only magnetic moment value more than 3 Bohr magnetons. So let's focus on the first part of the question first. So we have been given 5 metal ions and we have to identify amongst these 5 metal ions the ones which have a spin only magnetic moment value of more than 3 Bohr magnetons. Okay, and then we will move on to the second part of the question. So in order to do the first part of the question, we have to write the electronic configurations of the metal ions in their given oxidation states. So now you can see here that I have written the electronic configurations of the given ions in their given oxidation states. You can see here, cobalt in the +2 oxidation state has 3d7. Cobalt in the ground state has 3d7 4s2, and in the +2 oxidation state cobalt has 3d7 4s0. Okay, nickel in the ground state has 3d8 4s2, and in the +2 oxidation state it has 3d8. Then iron Fe +2 in the +2 oxidation state has 3d6. Vanadium +3 has 3d2 configuration, and titanium 2 plus has 3d2 configuration. Now the next step will be we will fill these electrons in the 3d orbital, and for that we have to take a look at the second part of the question, which says all of these complexes have to be considered in their high spin states. Okay, high spin octahedral complexes. So these are all these complexes are high spin complexes, and you know that high spin means weak field. Okay, and these weak field complexes show no pairing. That means they have no tendency to pair. That means all the 3d orbitals will be occupied singly first, and then only pairing will take place. Now I will write these electronic configurations of these ions in the next step. Now I will fill these electrons in the 3d orbital in the next step. So now I have drawn these 3d and 4s orbitals, and we will now fill these electrons according to their oxidation states. Okay, so we have 3d7, right? And we have these complexes as high spin complexes, weak field. Okay, so first of all the electrons will be occupied singly. So 1, 2, 3, 4, 5, 6 and 7. Okay. Now for nickel also, first these will be occupied singly. 1, 2, 3, 4, 5. Then 6, 7 and 8. For Fe2 plus, we have D6 configuration in the +2 oxidation state. So 5 and 1, 6. Okay, for V3 we have only 2 electrons that will be occupied in the 3d orbitals singly, and for titanium 2 plus also we have 2 electrons that will be occupied in the 3d orbital singly. Okay, now after this we have to now see how many unpaired electrons we have for each of these metal ions. Okay, so for cobalt 2 plus you can see 3 unpaired electrons. So let's write n equal to 3, where n is the number of unpaired electrons. For nickel 2 plus we have n equal to 2. For Fe2 plus we have n equal to 4, and we have n equal to 2, n equal to 2 for vanadium 3 plus and titanium 2 plus. Okay, now as we know the number of unpaired electrons for these metal ions, now we can calculate the spin only magnetic moment and check which of these ions have mu spin only, which is greater than 3 Bohr magnetons. Okay, so let's do that. Now we know that mu spin only formula is mu s equal to √n into n plus 2. So we apply this formula to all of these metal ions to calculate the mu spin only magnetic moment. So mu s, number of unpaired electrons n we put, and then apply this formula. And for cobalt 2 plus, we get under root 15. Okay. Similarly, mu s for nickel 2 plus is under root 6. Then mu s for Fe2 plus, number of unpaired electrons here is 4. 4 plus 2. So that is equal to under root 24. Okay. Mu s for vanadium 3 plus and titanium 2 plus will be same because they have the same number of unpaired electrons, 2 unpaired electrons, same as nickel 2 plus as well. We have the mu s, mu spin only values for all the metal ions. Now amongst these, we have to see which one should give the mu s value, mu spin only value greater than 3. So we have to find that value. So under root 15, okay, yes, that will be greater than 3. Okay. Under root 6 is not greater than 3. Under root 24, yes, it is also greater than 3. Under root 6, both are not greater than 3. So you can see very well that amongst the 5 metal ions, only cobalt and Fe2 plus, only these 2 metal ions give the mu spin only value which should be greater than 3. Okay. So we have got our ions. Now, let us see what is being asked in the second part of the question. The second part of the questions, you read carefully. It says the sum of unpaired electrons present in the high spin octahedral complexes formed by those metal ions. Okay. So they are basically asking that those metal ions which have a mu spin only greater than 3, you identify these 2 metal ions. We have identified CO2 plus and Fe2 plus, and then they are asking us to add their number of unpaired electrons. That is the sum of unpaired electrons of these 2 metal ions, and that will be the final answer to this question. So let's see how many unpaired electrons these have. So cobalt has 1, 2, 3 unpaired electrons, n equal to 3. Okay, cobalt has n equal to 3. Fe2 plus, number of unpaired electrons is n equal to 4. So let's say cobalt 2 plus has n1 equal to 3 and Fe2 plus has n2 equal to 4. So what is n1 plus n2? And n1 plus n2 is equal to 3 plus 4, that is 7. Okay. So our final answer to this question is 7. So that is our answer. Okay. So here is a small error. So previously I had written for nickel 2 plus, vanadium 3 plus and titanium 2 plus, which have n equal to 2, number of unpaired electrons equal to 2. Previously I wrote their mu s as under root 6. So not under root 6 but under root 8. Please correct it in your notes if you too have written it under root 6. So it is under root 8. Okay. So what we did in this question, we have to read the question very carefully, understand what the question is asking from us. So first of all, we noted the given ions in their respective oxidation state. We wrote the electronic configurations for these ions. Then we found out the number of unpaired electrons, and from those number of unpaired electrons, we found out the mu spin only value. And then we calculated that which mu spin only value is greater than 3. Okay, and then we identified those 2 ions, cobalt 2 plus and Fe2 plus, which have mu spin only value greater than 3. And then in the second part of the question, we have to add up the number of unpaired electrons of these 2 ions, metal ions, which have mu spin only greater than 3. So we added up the number of unpaired electrons for these 2 metal ions, cobalt 2 plus and Fe2 plus, and we got the final answer as 7. And all of this electronic configuration that we wrote was based on the high spin octahedral complex. So I hope you understood the explanation to this problem. And if you have any doubts, any queries, please write to me in the comment section. And also please do not forget to like, share and subscribe my channel. Till then, thanks for watching. Keep learning and see you soon with my next video.